Next week, we will not have any homework or any tests and quizzes because it's considered a midterm week. So I don't think that's fair that I start handing out homework and quizzes and tests for kids that got to study for a midterm. So this is it right here. This week, this test, this is it for quarter 2. It's not much. It's only 11 questions, 38 points. One of them is going to be a proof. One of them will be a proof. There's no shock what the proof is going to be here. We only went over one kind, right? Prove triangle similar. Maybe it'll be CSSTP. Maybe I go that extra step and do product of the means equals product of the extremes. You know you're in an honors class, so it's probably just not going to be as simple as prove these two triangles congruent by or similar by angle. Probably going to be a little more. So prepare for that. All right, prepare for that. 4 multiple choice. Why do I tell you that? Because some kids feel warm and cozy inside when I tell them there's 4 multiple choices on there. 2 questions, 5 points apiece. One's going to involve factoring and the other one's going to involve quadratic formula. All right? I will tell you one of them you can factor, but you can also use quadratic formula. That's fine. But the other one, you cannot factor. You're going to have to do quadratic formula, leave it in simplest radical form. Yes, I will be providing the quadratic formula to you. No need to memorize it, but you do need to know how to use it. All right, so 2 questions. One will be factorable, one will not be factorable. Any questions yet before I get to the other big part of the test, which is, 2 triangles are similar. Can you actually tell me what side matches up with what side in both triangles? Anything on 1 through 4 here? At home, here in class, anything I can answer on 1 through 4 before I get into it on number 5. All right, another big part of the test. You're going to know that the triangles are similar. And I just cut this out of, these are 2 old homework examples. I just cut them out of your textbook. You're going to know the triangles are similar. All right, you're going to know. How do I know these 2 triangles are similar? I don't need to tell you why. You already know. What method? Angle. All right, speaking of that, remember, yeah, you got angle, which has been the big one, right? But you also have 2 other ways, which could come up tomorrow. Anybody remember the 2 other ways? Angle, side, which means all 3 sets of sides are in the same ratio. All 3 sets of sides are in the same ratio. And then there's a third one called side angle side similarity, which means 2 pairs of sides are in the same ratio and the angle in between them are congruent. Don't forget about those other 2. I know it's not going to be used in the proof, but it still could be used in the algebra section. So yes, these 2 triangles are similar by angle. Here's my concern going into tomorrow and Thursday. If I just randomly take 4x plus 7, do we know what side it's going to match up in the other triangle? What's our plan to find what side it matches up with in the smaller one? All right, that's what I'm nervous about. And when we did this problem on homework, I said to you guys, hey, J and Q are congruent. H and N are congruent. So turn the darn things and make sure those angles land smack on top of each other. Then tell me the sides. And then after everybody left, I was like, you know what? Maybe some kids have trouble actually visualizing turning and flipping. Me included, guys at home. I have that trouble sometimes, visualizing it. So I was like, is there a different way I can show these guys what sides match up? And here's what I got for you. Take it or leave it. That 4x plus 7 I just picked out is across from what angle in that triangle? What angle is 4x plus 7 across from? Name it. K, angle K, right? What angle in the small triangle is congruent to K? P. And what's across from P? Oh, so they got to match up. So look for the congruent angles and then look for the sides across. They have to match up to each other. Let me take 6x minus 2. That's across from what angle? And what's J congruent to in the smaller triangle? Q, which is across from? All right. Maybe that's the way you want to match them up instead. Because sometimes I get it. I fall in this category that I cannot rotate, flip it, and see where the angles would match up, which would lead me to the sides. All right, one doesn't make you great. Look at my other example here. Anybody know why those two triangles are similar? By what method here? Well, you got what? 22 and 22. If that's a right angle, what's next to it? So this is angle as well. Yeah, angle as well. All right, so here you go. I'll take 12. Can we figure out what 12 matches up with on the other triangle? Well, I see 12 is across from angle A. Anybody tell what angle A is congruent to in the other triangle? Angle FDB, this one. And what's across from that angle? All right, there we go. They got to match up. And then what's my other one? 20. 20 is across from what? What type of angle is 20 across from? The right angle. So what's across from the other right angle? All right, there we go. So now I know what matches up. Okay, now I know what matches up. So there's enough. You're going to have to do that for a couple problems tomorrow. And it's not going to be that easy just to match them up. All right, you're going to have to think about, okay, this side's across from this angle. So this angle's congruent to angle N. So what's across from angle? Okay, so the 20 matches up with it. All right. Everyone all right there? Any questions on the topics going into tomorrow? Last opportunity to move that needle on Aspen. Anything at home, guys, you want to ask about these topics? Going. Okay, where can you study from? As usual, in your packet. Everyone, please, if you're not there already, go to page 30 in your packet. Please omit number 1 from there. All right, we were supposed to talk about that on day 1, but due to time constraints, I ended up tossing it. All right, so number 1, don't have to worry about. And once you're done crossing out number 1, can you go to number 13 for me? Go to number 13. All right, so please omit number 1, then go to question number 13, which I believe is on page 33 of your packet. And look at that diagram on number 13. You will see side BC has a point on it that's not labeled. That should be point E. Okay? So on side BC, there's a point there. On side BC, it should be labeled E. If it's not there, it's going to be hard to answer one of those questions if you don't know that's an E.
Doesn't matter if I'm knowing the point on AC.
What's that?
What about the points on AC?
I don't think that's going to matter. Okay. But just to answer the part B question there. All right, everyone good? Okay, so you have all those questions right there in packet pages 30 to 33. You have 13 questions. The work and answers for those are on the following pages. And then, as usual, I have some textbook questions to try, which are on page 30 as well. You don't have to copy these down, but those are on page 30. Answers are also in your packet. The only thing I didn't do for this unit test that I did for the last couple is put some extra practice questions on Classroom. I just couldn't find any. All right, that would do you guys any justice. All right, so we're sticking with the textbook questions and we're sticking with the 13 packet questions to help you guys get ready for the test tomorrow or Thursday. Questions at all about this? Anything? Yes, Sophia, what's up?
I mean, just looking at it, how are we supposed to set up something like number 2, like a word column or something like that?
Okay, so we're given certain values. So number 2, we want to start there. Number 2, we're given certain values. And then I wanted to do number 5 with everyone here before we left. All right, so here's number 2. You got a kid who's 5 feet tall, so I'm just going to start drawing the diagram. I got a kid who's 5 feet tall. And the measure of a flagpole is 60 feet tall. So we're comparing his height to looks like a flagpole's height here. 60 feet. And he places a mirror on the ground 4 feet away. So here's Nate. He places a mirror somewhere on the ground 4 feet away. So that mirror is also, I don't know how many feet away from the flagpole. And then how far away is the flagpole from Nate? So here's the flagpole. Here's big dog Nate over here. What's that distance from him? Okay. Now, if I wanted to, I could complete the triangles here if I wanted to. I don't have to, but if you want to complete the two similar triangles there, you can. Now I got to set up a proportion that matches up the corresponding parts. One ratio is going to be Nate's height to the flagpole's height, 5/60. That's going to be in the same ratio as Nate's distance from the mirror to the flagpole's distance from the mirror. I'll call it Y for now. But that's not going to be my final answer. Here's why. Everyone understand that when I find the value of Y, I am finding the distance from the flagpole to the mirror, but it wants me to find the distance from the flagpole to Nate. So what I'm going to have to do with my answer at the end, whatever this turns out to be after I cross multiply, I'm going to have to add 4 to it. So whatever Y turns out to be, plus I'm going to have to add 4 to it.
Why do you know to put Nate's height as Nate's height over the flagpole's height?
What else is it going to match up with? Height to height, right? Right? That's the only thing I could possibly put it together with is his height to flagpole height. There's 2 heights here, his height and the flagpole height. So that's how I know to put them together. And there's 2 other things that go, which is his distance from the mirror, flagpole's distance from the mirror. And I combine those 2 and I get the total distance between Nate and the flagpole. All right. Can you guys go to number 5 for me? This is one I wanted to do as a class because it does involve some factoring. And one last time. So I'll let you guys go ahead and set up that diagram. Set up that diagram, number 5. Point D is on AB. Point E is on AC. Doesn't have to match mine. Here we go, DB. What are we doing with this here? BC is 2 more than AD. What are we doing on our diagram there? BC is 2 more than AD, find AD. What are we putting for labels here? BC is 2 more than AD, and I need to find AD. What are we putting on there? Go ahead, Omni.
Maybe X plus 2. Maybe X plus 2.
X, I'm going to put AD as X because that's what I'm trying to find, and I'm going to put BC as X plus 2. Yep. All right. We know, why are the triangles similar so I can do a proportion? You got corresponding angles here, and you also have a reflexive angle at A. So you could say they're similar by angle. All righty. First battle tomorrow you're going to have to fight. Can you come up with the correct proportion to solve? That's your first battle tomorrow. Because, quickly, is this side splitter, anybody? Can I apply the side splitter theorem here? No, it does not split the parallel sides proportionally. Side splitter is a no-go. So I am forced to match up the sides in the small triangle with the sides in the big one. And that's what somebody's going to do for me right now. Oh, here we go. Going deep. Hannah, can you give me a side in the small triangle, please?
8.
8. What's the 8 match up with in the big triangle?
X plus 2.
There you go. 8 and X plus 2 match up. So that's why they're over each other. All right, what about the other 2 sides now? The other 2 sides I need to match up. 2, 1. Here we go. Zach, give me the other side in the small triangle I haven't used yet.
X over X plus 5.
Good. X, not over 5. 5 is not a full side in the large triangle. It's X plus 5. There it is. There it is.
Why did it say And why is that specifying the instructions only in algebraic?
This is why, all right? This is exactly why. In the parentheses, and it's very easy to overlook this, it says only an algebraic solution will be accepted. What that means is you guys can't think of a random number in your head, plug it in and see if it works. Guess and check is not going to work. And those exact directions will be on there tomorrow and Thursday. Meaning, do some darn algebra. That's what I'm asking you to do with that direction in the parentheses. Because somebody could easily pick, I'm going to pick 6, and they plug in 6 and see if both sides work. No, you're going to do some actual algebra here for me. So we cross multiply x times x plus 2 equal to 8 times x plus 5. It's not going to be that easy. You might have to FOIL or double distribute tomorrow or Thursday. You're going to have to FOIL or double distribute, so be prepared. X squared plus 2x equals 8x plus 40. I'm going to fly through this because we've had so many reps in this unit doing these types of problems. Get one side equal to 0, but when you do, make sure whatever's with the x squared is positive. So it's positive already. X squared's already positive. Move everything else over. So subtract the 8x. And I don't care what method you're going to use, factoring or quadratic formula, you still have to get one side equal to 0 before you do anything. Move the 40 over. Subtract it. X squared minus 6x minus 40 equal to 0. Now from here, it's your call from here. It's your call. You can either use quadratic formula or factor. I'm telling you, if you use quadratic formula, you better know how to use that thing. Oh, well, he's giving it to me. That's great that I'm giving it to you. Great. You still got to use it. But being in an honors class, I'm factoring if I can. I could find two numbers that multiply to 40 and add to 6. That's what this deal is here. Two numbers that multiply to 40 but add to negative 6. Again, you want to use quadratic formula, feel free. I just hope you know how to use it to get our final answers here. X. I am going to ask somebody here, two numbers that multiply to negative 40 but add to negative 6. So start thinking about numbers that multiply to 40. There's a decent amount, but not too many. 2, 3. Here we go. Luke, got any numbers that multiply to 40 but are 6 apart?
Negative 10 and 4.
Yep. Negative 10, positive 4. Good job, Luke. Negative 10, positive 4. One more step. Set each equal to 0 here. I get x equals 10 as a solution. And I get x equal to negative 4. Be on your toes tomorrow and Thursday. This did have a diagram. So negative 4 can't be a solution because AD would be a length of negative 4. Can't happen, right? So therefore, I have to reject that one and just keep 10. Okay? Yep.
Would it matter if I got the length of BC and then plugged it back into BC minus 2 equals AD? And then got
The length of...
BC.
Okay, what about it?
Well, I answered it by getting the length of BC and then I subtracted 2 and got 80.
Yeah, that's fine. Yep. Couple things here before I end this problem. Even if you use quadratic formula, you still got to check both answers, remember. Because when you use quadratic formula, you could still reject one because it makes a negative side. Remember that. Second thing, no diagram, don't worry about rejection. Okay? There's no reason to reject an answer if there's no diagram. The reason why we reject is because it gives us a negative side. So if there's no diagram on there, keep both answers. You don't even need to check a darn thing. All right? Any issues with this one here? Okay. I will. Go ahead. Go ahead, Radhika.
Would you have to write a let statement whenever you have to like put x in for a side?
No, because you've already put it on your diagram. So I'm assuming that when you have 10 as your answer, that's the value of AD. Because you put it on. If you don't label your diagram like I did, then yes, I would need a let statement there. Let x equal AD. Yep. Other questions? All right, I'll be after school today and tomorrow, depending on when you want to stop by. That's up to you. All right, I can't stress it enough. Last opportunity to move that needle on the average. This is it. No opportunities next week because there's not going to be any homework or test and quizzes. All right, so you guys at home, I'll see some of you guys tomorrow. If not, the rest of you guys will be watching the Unit 8 Day 1 notes. Let me know if you need a packet today through email. All right, have a good day, guys. With this here. No, that's here. I wasn't looking, if you take a look, determine which postulate, I was actually looking for one of the 5 methods here. See what I mean? Okay, you were telling me like part of a proof here that these are equal because of that, like maybe what else you would need, but I want to know why are these 2 triangles based on some of the 5 methods? Okay, and the same thing applies for number 3. Okay, you were giving me like, okay, the right angles are congruent, but I want to know one of the 5 reasons why those triangles are congruent. Okay, so I'll look at that now instead, because you don't have a grade yet and ask for it. That's why. Okay.
I also was wondering about perimeters and Marshall, right?
Whatever the ratio of the sides are, that's the ratio of the perimeters. So if the sides are in a ratio of 2 to 3, the perimeters will also be in a ratio. That doesn't mean the perimeter is 2 and the other one's 3. They'll be in a ratio of 2 to 3. Okay? But yes. All right. I'll see you guys on Thursday either way, whether it's here or at home. All right, do we need to get out of here and just move to a different one?
What do you mean?
Like a different level of expectations for math classes? Because this whole thing is over. I'm over it.
Yeah.
It's laziness. There's no excuse for it.
I was just
Okay.
trying to get it done in between periods and during my lunch period and stuff, and that obviously wasn't working. So last week I started to do it as homework with the rest of my homework.
It's just another excuse, Quincy. That's all it is.
I know it's my fault. I'm not making an excuse.
But you're just, well, it would have happened at this or this.
I shouldn't have been doing it during lunch. That's why I moved to doing it after school, the rest of my homework. And normally I check Google Classroom, and that's why. Because I forgot that you don't put it on Google Classroom.
All right, well, I've let it go, and nothing's changed, so I got to involve Mom now. I'm just letting you know.
All right.
So I'm going to email her to let her know because we've tried to do it by yourself, but that did not work.
Yeah,
Okay, so
we've talked about it because she already gets notifications from Aspen when I get a 0. So
Okay.
we talked about it, and
all right, well, I'm just going to let her know from my end too. Okay, because I tried to do it with you and it's not working.
Yeah.
All right, all set?
so do I like write on this or like?
You can just write right next to here just what your method is. Okay, and then I'll go back and finish grading it.
Boston finally lost the Coliseum.
Finally, good.
The final, 1-0.
Yeah.
Hey, you want to take that for your door? Because Pete thought they had this class in here.
Yeah, I'll do it on the
Yeah,
way.
yeah, all right. All set. Thank you, sir.
Thank you. Thank you, and see you Thursday.
All right, I'll see you then.